All right, so our first example for the binomial. If we read through the question stem, I want us to point out how we would know we're dealing with a binomial situation. So according to the USA Snapshot, Knowing Drug Addicts, 75% of Americans know someone has become addicted to a drug other than alcohol. So here we have a probability of an American knowing someone has become addicted to a drug other than alcohol. Suppose we randomly select 15 Americans from the population. Does X, the number of people in our sample who know someone has become addicted to a drug other than alcohol, follow a binomial? Check the properties. So on the next exam, the easiest way to know you're dealing with a binomial is that as you're reading, you're going to have your N and you're going to have your P. Now, technically, you still need to check your different pieces, but this is your heads up that you're dealing with a binomial. Because we have a probability of success and we have our fixed number of trials. We just need to check the rest of bins. So let's check our properties. B is that we have binary outcomes. In order to check this, we actually have to show that we have done this work. So our success is knowing someone. And our failure is not knowing someone. Right? It's very easy to make binary when we have a success. With the failure is just not that. So we got that. I is that our different observations are independent. So what about this question stem lets us know that we're dealing with something independent? Well, we randomly selected these people. And if they're randomly selected, that means one should not influence the next when it comes to whether or not they know somebody. So we also have our independence. N is for N equals our fixed number of outcomes, our fixed number of trials. So in this case, we already figured that out. We saw that our N was 15. That was our sample size, or our number. Each person's an observation, or we don't really know what's going to happen with them, whether they know or don't know someone. And last is our S for success stays the same. So something to show that our probability is going to be the same for each one. And since we have a probability of 75%, there's no reason to assume that this is going to change for each person, especially if we're just randomly selecting. So we're good there. We have our P and our Q. We also have S. So because all of this is true, here's the problem that a lot of you are going to have on the worksheet. Answer the question. It says, does X follow binomial? So the answer is yes. X is approximately binomial with a N of 15 and a P of 0.75. Now you don't have to write the actual notation here, but you just have to say, yes, X is binomial. So now that we've determined that it's binomial and we've translated everything we need, we're going to use that formula to find probabilities. So the first one says, find the probability that exactly 6 of the 15 Americans know someone who's become addicted. So probability that our number of successes, which is our X, is equal to 6. Now we could use the formula, which is on our formula sheet. But if you go down to the bottom, let me see, yes, if you go down to the bottom, we also have this sweet formula or shortcut for the calculator. So I'll do this both ways. If we use the formula, this is, what's our N? 15, choose 6, probability of success, well, we need 6 people to actually know someone, so 6 of those 75%, and the remaining 9 people must not know someone. All right, so let's bring up our calculator and see what this is. Boop, calculator. So first thing I'm going to do is type in the 15, then go find my NCR, and then do 6. There were 5,005 ways to order these 6 successes within the 15 slots. So this is why the combinations formula is super useful. And then we're going to multiply that by our 0.75 to the 6th and our 0.25 to the 9th. So we get out 0.0034. And now while I was telling you guys with the TI-36X not to freak out about finding NCR, is because we're never going to use this if we have the 36x or we have the 8483. Instead, what we should be doing is that thing at the bottom of the page. We should be using binom PDF. So let's just write this down. Binom PDF. The P stands for probabilities. We're looking for just one probability. Our N is 15. Our P is 0.75. And we are looking for 6 successes. So where do we need to find this binom PDF command? This binom PDF command will do this exact formula for us without us having to type into it. So you're going to find this in the same place for both calculators. It's in the distribution menu. So second and vars takes us into distributions for the big calculator. I'll post up a video of the little calculator, but it's second and data for the little calculator. And then you're going to go and scroll. For the little calculator, it's not as much scrolling, till you find binom PDF. If you have a wizard, it asks you for the trials. It asks you what P is. And it asks you what the outcome is that you're interested in. If you don't have the wizard, you have to type these things in with commas. It's actually easier to me without the wizard. And it gives you the exact same value, 0.0034. So way quicker way to do this. So that's what I'm going to do from now on. But if you have a calculator that doesn't do this, you'll have to do the formula. All right, so let's look at the next two. We're still finding probabilities, but now things have changed. In the next one, we're looking for at least 14 of the 15. So if you're thinking about the mathy way to write at least is a greater than or equal to. What I find is that when students try to translate things directly to the inequalities, they make some mistakes. So what I like to do instead is to write out our little list. Start from none, go up to all. So 0, 1, 2, I'm going to be lazy, 13, 14, 15. So if we're going from none to all, we can now actually see and visualize, and this is the one thing that you guys aren't going to want to do on the worksheet, and if I were there, I wouldn't even help you unless you had written out this list of values. If you haven't written out this list of values, I'm not going to help you with the worksheet. So write out the list of values, and now at least 14, it's a lot easier to see that that's going to be 14 and more. Got to be at least 21 to go to the bar, so at least 14 is 14 and more. So now we can see that this is just binom PDF because we got to do it for the 14. Still type in our N and our P, they haven't changed. And we need to add that to binom PDF of 15. Oops, that's not 75. So if we're doing that, here's a quick trick, especially if you're doing this for the worksheet. If you do second and enter, it'll bring back whatever you last typed in. So you'll be able to just change out your values really quick. So this is 0.0668. And I'll bring it back again and change that to a 15 plus 0.0134, which is equal to 0.80802. Now there is another way to do this. If you look at the bottom of the sheet, we do have binom CDF. C stands for cumulative. And what CDF does is if you have your entire list of values written out, it adds up everything from 0 up to a value. Now, this is useful if you circled the left side of your binomial, right? Your little list of values. In this case, we circled the right side. Now, we could use the fact that what is all happening when we add all of this together? This should all sum to 1. So if I wanted to use binom CDF, I could. But since I want the other side, I'm going to do 1 minus, and then I'm going to do my CDF up until 13. Because CDF up until 13 is going to add up 0, 1, 2, 3, all these things up till 13. And then if I subtract them from 1, I'll get the other portion of this little list of values. So just to show you that, and prove that it's the same value, let me pull up CDF. Oops, that's not there. Binom CDF 15.75 13, and we'll do 1 minus that answer. Same thing, 0.0801 or 0.0802, right? So same exact value, just a different way to get there. And what I'll do is I have a part 4 in the part 5 folder. There's a quick cheat sheet that shows you all the ways that you can have this work out. It'll be very, very useful for the worksheet. So I strongly recommend checking out that binomial cheat sheet, maybe having it open on your phone for the worksheet in next class. So our last probability here, so we can finish up this very long video, the probability of not all of the 15. So again, this is really hard to think about in terms of, I don't know, my brain. And I actually have to do this every single time. All would be 15, so not all is everything else, right? This is actually what I'm interested in. Not all. I want this, which is the perfect setup for CDF, because we circled the left side of this. Also, I could have done the fact that we, as we saw in part 4 with the sampling questions, probability of not all is equal to 1 minus the probability of all, because they're complements. So this is 1 minus probability that x is equal to 15. So I also could have done this as 1 minus binom PDF for that 1 at 15. So there's just 2 different ways to get these problems. So you can always see these problems with binom PDF or with binom CDF. It's really whatever you're more comfortable with. I usually tell students to do PDF if they're uncomfortable, because it lets them have more control over what they're doing. Although PDF, for this one, you'd want to add up all of those, which is crazy. So it does make you sort of think about which side is easier to do. And then I guess I'll give you the value for this, even though I don't want to do work. Distributions. I'm doing this on my little calculator. N is 15.75, and we're looking for 14 for CDF. So this is 0.9876. Or 67, sorry. Perfect. If you want to see another example, I'll do the next one, and I'll have Professor Steele do the last example before you guys have your worksheet in class.